The learning objective of this chapter is to know what information is displayed on an ECDIS. The ECDIS has a menu system that allows information windows to be displayed either on the chart or on the surrounding pane. The illustration shows that windows appearing on the chart hide detail, but when the menu pane is used, there is a reduction in the amount of screen available for the chart display. The illustration shows that some information will always be visible on the ECDIS display, like position of the vessel, course and speed, chart type, chart scale, depth unit, display mode, and the menu. The ECDIS has settings to dim down the chart display when the ambient light level is low, protecting the operator's night vision. As you can see, it's not just screen brilliance that is changed. The sea, that would normally be displayed as white or light blue, is now displayed as black or dark grey. Click the buttons to switch between day and night mode. A monitor color check should be performed at least once a year to ensure the monitor is displaying chart colors correctly. The chart illustration shows colors as follows: yellow representing land, the intertidal area between high and low water as green, and water depths as white or various shades of blue. Cross-hatching can be used to highlight a depth area inside a contour. The illustration shows that individual depth values, potentially dangerous to the vessel, are more easily seen when shown in a bold font. The ECDIS always displays the direction of true north on the chart using the illustrated symbol. When ECDIS displays a gnomic chart at small scales, the direction varies slightly across the screen because of the chart projection. On a large-scale chart, the vessel's symbol correctly represents the vessel size, and is particularly useful for observation of clearances when manoeuvring in harbours. On a small-scale chart, the outline is too small to be seen, so the ECDIS simplifies the representation and uses a circle. In north-up true motion mode, the vessel symbol moves across the screen and chart until it reaches a predetermined value close to the screen edge. At that point, it resets itself back to the other side, updating the chart display at the same time. In relative motion mode, the vessel symbol stays in one place on the screen, with the chart updating continuously as the vessel moves. A course upsetting in true or relative motion has the heading marker pointing to the top of the screen. As the vessel yaws, the heading marker moves. In head-up mode, the heading marker points to the top of the screen all the time. As the vessel yaws, the ECDIS reorientates the chart in sympathy with the heading. This can cause problems on older systems where the ECDIS computer is not powerful enough. An ECDIS is capable of operating in several different modes. It can be used for planning passages, monitoring the vessel whilst on a passage. It can play back a voyage recording, and sometimes have more specialized uses, such as docking, lock mode, and offshore tanker offloading. Browse mode allows the operator to view the chart in areas not close to the vessel's position, and is a useful way to look ahead whilst on passage or at other charts when planning. It is required that the chart display returns to the vessel's position with a single operation. Some ECDISes allow a split screen function for the look ahead, enabling the vessel symbol and hence position to be visible at all times in one window. The illustration shows a chart zoomed to a scale of 1 to 4000 that is beyond the chart compilation scale, the chart now being overscale by a factor of 10. From CBT1, ECDIS Systems and Chart Types, it will be remembered that the compilation scale is important because it dictates the level of detail shown on the chart. When over or under scale, important detail may not be visible. The illustration shows a raster chart loaded on ECDIS, indicating there is a better chart available for the shaded area.
In 4 shades display.
SCARMIN is a feature of a vector chart that influences when an object is removed from or added to the display to prevent clutter. A poor scarmin produces an over-cluttered display, as illustrated. The operator can, however, manipulate the display to make it less cluttered. Click on the button. Chart producers have recently reached an agreement to apply the same level of scarmin to objects, making future charts react the same way when zoomed in or out. An ECDIS can be set in base display that shows a required minimum amount of chart detail. When in standard display, more detail becomes visible. Click on the buttons for more information. Mouse over hotspots on the chart to see requirements for the base display. Mouse over hotspots on the chart to see requirements for the standard display. Mouse over hotspots on the chart to see further information displayed. It is required that the operator is able to return to the standard display using one button. The illustration shows a chart themes menu with a standard display window ready for use.
Most ECDIS models have menu windows that open in the chart area. Some are movable, while others are associated with the cursor position. The hover over text box is a useful feature for passing small pieces of information.
Boys can be represented with traditional symbols or simplified symbols that are less complicated to draw and assist low-specification computers running ECDIS. Traditional boy symbols have shapes the same as on paper charts, but are outlined rather than filled with colour. When lit, they show a magenta flash. Click on each button to see the associated symbols. Click on each button to see the associated symbols. The traditional paper chart symbol for an IALA Region A or B green lateral buoy is a black filled shape, as shown in the illustration. The IHO presentation library shows them without black fill. Both red or green filled and unfilled traditional symbols can be found, depending upon the chart maker. Another difference is the symbolization of a buoy light. Some charts show a traditional symbol with red, green or yellow flash indicating a light. But traditionally it was a magenta-coloured flash. The isolated danger buoy is a special case because of the traditional symbol having two black spheres that would not be visible on the ECDIS set in night mode. When buoys and beacons have numbers, the chart shows the number prefixed by the letter BY for a buoy and BN for a beacon, to stop the number being confused for a depth sounding. Simplified beacon symbols are displayed upright, representing a beacon mounted on the seafloor. When the ECDIS has difficulty establishing the characteristic of a buoy or beacon from the chart dataset, it will draw a grey object, either round or rectangular, and sometimes show a magenta question mark alongside it. The simplified symbol for an emergency wreck marking buoy is either a blue and yellow sphere or inclined rectangle with top mark as illustrated. This buoy is deployed using a fast response craft soon after a new wreck, but is replaced with other marks if the wreck remains on the seafloor. Let's summarize what you have learnt in this chapter. A basic amount of information is always displayed, and there can be a base or a standard chart display. The displayed colours are important as they pass information, particularly on water depth. We've learnt that the ECDIS has north up, course up true, and relative motion capability. That the ECDIS has various modes of operation: planning, monitoring, and playback. To set the correct scale for the chart in use. That there are simplified and traditional buoy symbols available.